Hi everybody, I'm Imran Malik, cassava production system specialist at CIAT. I'm going to present the objective 4 of the project, establishing sustainable solution to cassava diseases in mainland Southeast Asia. Objective 4 focuses on develop and evaluate economically sustainable cassava seed system models for the rapid dissemination of new varieties and clean planting material to farmers in different value chains and production contexts. Achievement and lesson learned will be discussed in this presentation, and then going to talk about research to be done and priorities that cannot be addressed in the current project but could be included in the future projects. Detailed activities and the result you can hear from the respective country presentations. Objective 4 has got 4 activities, and in the proposal we have put the method and the output assessment and the risk and application of the output. That's what we try to achieve. I have put up this slide from the proposal, and just to remind us all what we are aiming for. For activity 4.1, we have developed many communication materials for publication, and also as a brochure and sometimes YouTube videos and the training manuals. You can hear more about it from Eric Delica's presentation. I have put up a list here, and all are available online. You can click the link and can have a look at it. Objective 4.2 is the evaluation and on-farm demonstration of CMD resistant exotic cassava varieties from IITA and CTCRI against clean available Southeast Asian varieties. In activity 4.2, we plan to assess exotic varieties against Southeast Asian varieties for disease susceptibility and yield. So in Cambodia, we have done CMD experiment and also CMD and CWD experiment. CMD experiment is completed, we have done for 3 years, and we saw the variation in disease susceptibility among the varieties. And we also submitted a manuscript, and it has come back with a minor revision last week. So this experiment is ongoing, and we want to include round 11 in this experiment, as round 11 is reputed to be CWBD beta tolerance. So we need to do another couple of years of experiment. For now, we are doing CWBD experiment, round 11 and KU50, and we have got fertilizer treatment in there, and we did see the positive effect of fertilizer on the yield, but we didn't see much on the infected rate, whether the fertilized pots are more infected or not, less infected or not. We didn't see any difference there. For Vietnam, we did a CMD experiment with different varieties, and there was high disease pressure, and even with high disease pressure, clean planting material gave higher yield compared to other planting materials. You will hear in detail from respective country presentations. Here is the summary of all the results from activity 4.2. So what we have seen in the experiments has been done in 3 different countries. We saw that the early infection got lower yield for CMD, and that also true for CWBD, but we don't have enough data to conclude that. Then for CMD, moderate disease pressure Ku50 is consistently producing reasonable yield. You can see it here. And clean planting material gives 2 to 3-fold higher yield than disease planting material. We did another experiment with the asymptomatic stain of a symptomatic plant, how they behave when they are growing in as a crop. So we found that asymptomatic stem of a symptomatic plant can be used in extreme situations. So like if the farmer cannot find any clean planting material, so they can be go into using the asymptomatic stem. That's what we have seen in this experiment. And at higher disease pressure, variety responded similarly in Vietnam. You can see it here. But it is still showed that the Ku50 is doing better. And so for now, the current advice for to start with the clean planting material for CMD and for any diseases, and we also recommend with the current situation Ku50 and rank 72 or Hoibong 60 can be used for in CMD situations, and for CMD we need to avoid rank 11, variety 89, and SC8 and HLS 11. In this slide, I have put the list of the varieties that we aim to test against the local varieties. Experiment has been already done in objective 2.4. You have already seen this data that has been experimented in Vietnam, and the results are promising, and some of the varieties are already released in Vietnam, and CTCRI is in the process of sending these materials to see it, and then we can start after evaluation we can start the 4.2 activity, that is to multi-location trials in different agroecological zone. Where you can see the timeline of the completion of output for activity 4.2. So you can see the IITA material will be in multi-location trial in all the countries. CEAT material will be only included in Vietnam. For CEAT material, Laos and Cambodia has just received them in vitro, so it will take quite some time to multiply them in vitro and then into the field. But then we will have enough planting material to go into the multi-location trials. So these are has been selected from the Vietnam experiment, as I mentioned in the previous slide. And CTCRI materials are in process of arriving in CEAT. Activity 4.3 is the evaluation and comparison of rapid multiplication innovation in Southeast Asia contest. Desktop review has been done, and you can hear about it from Eric Delac's presentation. From this review, we set up the technology that is appropriate in the region. We started in Vietnam and Laos, and also in Cambodia, and we also did some capacity building for the rapid multiplication technology. So here are the outputs and the method that we have used for this activity. So here is the different steps of the rapid multiplication that are being taken in the region. So in here you can see the photos of different photos from example of Laos. So like all the materials has arrived in Laos and in Cambodia or in Vietnam in vitro, like in the tubes, and then they go through multiplications, the shoot multiplications, and then it goes to the rooting medium. Once the roots are formed, then it goes to the hardening process in the and transferred to a soil medium, and then they grow for 6 weeks or so, and then transplant them into the field. Then it grows at least for 6 to 8 months before it goes to the tunnel system for multiplication. So there are 2 nodes cuttings are planted in a tunnel, and here is the photo from Laos again. So approximately 35 plant are 2 long stem for each plant, give about 702 node cuttings, and then after couple of weeks you can see all these are coming up. Then at 5 to 6 nodes they are cut and transferred to a rooting medium. So initially it was started with KU50 and RAM11 at Laos, and now they are also growing in KU50 in Cambodia and in Vietnam. They are also multiplying exotic materials as well. Laos also has started tunnel multiplication for exotic planting materials. So after transferring this to the rooting medium, they grow for about a month. When the root comes out, they have been taken out from the plastic vessel and put them in the ground. But now we have introduced a fiber cell machine, so where rooting mediums are wrapped with a paper, so we don't have to take out the plants from the tray. So we can just take the fiber cell and put directly into the ground. So that saves quite a bit of time as well, and loss of planting material too. Tunnel multiplication has become quite popular with the private companies, and we have developed a partnership with a Kunsap company in Champasak province, and they came to see a tunnel at Laos, and then they set it up with our technological help. About 10 multiplication tunnel, and then here is the here they're cutting their tunnels, and we also did an experiment with them in their field. But there are some lessons learned also. I will discuss in a later slide. So here is the tunnels and the screen house in Laos at Nafri, and this is in the Kunsap land. So here is the productivity of the tunnel. This is an initial data at the start when the Laos tunnel system was not automated properly. So the irrigation system was hand and manual operated. Now we have upgraded that one with a automated system, computer control. So you will hear more about it from a respective country presentations. I just put the data here that how fast we can actually multiply from this tunnel system. So in general, the multiplication rate is about 6 to 10 times, but with the tunnel system, it is 100 to 125 times. And the time taken are are written here, and you can see that almost every 2 months we are getting about 6,000 planting material from each tunnel. Sorry, 1,000 planting material from each tunnel every 2 months. So for 6 tunnel, you are getting every 2 months 6,000 planting materials. Here I have summarized the activity 4.3 about the setting up of the viable technology. You will hear more about it from Eric Deleke's presentation. Activity 4.4 is the optimize agronomic practices for the economic production of both cassava roots and clean planting materials. Before going into the experiments, I would like to draw your attention onto this cropping calendar. This is an example. So like you can see that this is the 10-month crop. So this is the planting time and this is the harvest time. In different country, it would be it can be a little bit different, but farmers try to put their crops on the ground at their optimum time, but sometimes also do the harvest a bit early because of the price. So the crop duration can be different in different season. If you plant in January, then by October it's matured, and then you can wait for another 4 to 8 weeks and then plant them, and then it can come back in July. So it's a different season. And then if it's a 6 months, when the season a bit early, then sometimes farmer harvest it early. So like if they harvest in July, then whether they get equal amount of yield or not. So we try to evaluate that, how much farmer can be benefited by harvesting early or going for a long crop or not, and also the need for different type of planting. So whether there is a need for irrigation. So that's one thing. And on the top of it, as this rapid multiplication tunnel system is becoming popular, and it will be needed in the region for dissemination of new varieties and also for clean planting materials. And every 2 months, planting material will come. So we need to know that how these crops behave when planting in different time or harvesting in different time, and what is the need for water for this crop. Here is the summary table of the different harvesting date experiments. So we have done in Cambodia, in Laos, and Vietnam. So one of the goal was to compare the yield and the between tunnel grown plantlets and the stake grown plantlets. But at the start we don't have that the tunnel grown plantlet, so we try to understand the effect with different harvest time with the stake grown plants. So we have found that the longer duration crop yielded highest. That's we expected, but that need to be calculated with the economic advantage if farmers harvest early, because sometimes early in the season the price is a bit higher. We also find in Laos that the late planting may have lower yield with a similar duration crop. In Vietnam, we have seen that the dry season planting can lead to even a crop failure. So in this slide, I have summarized some of the results. You will see these results in different country presentations. So in Vietnam, you can see, and Laos, you can see that the highest yield was obtained when it is irrigated, and also in the longest crop. We are also calculating the water inputs. I haven't put all this data here. We are also doing a collaboration with another project on this water calculation, the ICI project. And for late planting, we have see that the late planting may have lower yield in Laos, and for Vietnam, you can see in here that in the dry season planting, it didn't get any yield because the crop establishment was very low. We have also done planting density experiments in all three countries, and here also the aim was to produce more planting material and planting material. That means if we put higher density, so we will receive more planting materials than whether we are actually seeing any yield penalty or not when the plants are densely planted. But at the same time, we also tried different fertilizers, whether a fertilizer rate, whether which one gives the most benefit in the yield and also in planting healthy planting material. So all these experiments are ongoing, and in some places we managed to compare, but between stake-grown plants and tunnel-grown plantlet. But in Cambodia and Vietnam, we haven't managed to do that. In Laos, we have only done it for 1 year, so we need to do these experiments more. We have got some indication that in some cases there could be some differences, and in some cases there may not be any difference in yield. But we also need to test the health of the whether density, highly dense planting material has got different vigor or not in the following season. Here I have put the timeline for objective 4.3 and objective 4.4 for rest of the projects. So the rapid multiplication will continue, and in vitro multiplication and maintain the valuable germplasm will continue. And for density trial, we will start in March, and then over by March 2023 for the density and different planting date and the multi-location trial. But these are only for the 1 year experiment. So most of the experiment will be finished by 2023 for this therefore. But as I mentioned before, that other exotic planting material, disease-resistant material, wouldn't be able to in this experiment during the duration of the project. Till now, we have focused on the multiplication. However, it is very important to think about the multiplication is in a sustainable way. So we need to make sure that viable multiplication option should be taken up. For that, we also need to know the soil fertility status, where the multiplication is going on, and also we need to know whether there is any relationship between the soil fertility status and also the disease prevalence. So for that, we have developed another objective to implement, and that's to evaluate the impact of soil fertility and management practices on the prevalence and incidence and severity of the cassava diseases. So that will be done, and but this is a very short activity, I would say, because it's in 1 year we really cannot implement or come up with a with an example of how to do the sustainable management of the farm. We can just plan and do some and maybe give an indication how to manage sustainably at least the farm. So in this activity, in this objective, there will be four activities. So there will be a review on how all the previous experiments for farm management has been done, existing cost and the potential market incentives for that, and establish a relationship between the crop management, soil fertility and soil physical properties, and cassava pest and disease in Laos and Cambodia. Initiated on-farm trial for evaluating impacts and trade-off different cropping system. In the previous slide, I have shown you one of the green manure that are being used in different cropping systems. We can try that one, but as I said before, that it will takes time to see the effect of the cropping system, alternative cropping system. So we can just plan for this, and we can give an indication. Then the develop and implement of a research station management and investment plan. So, with the current idea and the review and what we see on farm result train, we can come up with a plan. So at least at the end of the project, we need to make sure the multiplication blocks on stations are being managed sustainably. So these are the timeline for these activities. So I put it here. And from there, and hopefully we'll be able to come up with a plan and maybe go into a bigger project from this output. So these are all the partners that we have collaborated, funded the project. Thank you.